Fresno State Physics Outreach is a group of science students learning to teach science. So here now is Don Williams, the professor behind the Traveling Student Scientist Group. All right, so you're the professor who teaches the students, and then you go around and you teach other students with your students.
That's it.
So science and students, and every time you're on, you show me a little bit of what you show your students to teach the other students that you teach. All right,
I treat you as a student.
Yes,
that's what I do.
I am one of your best, worst students. All right, what are you showing me today?
Well, today we're going to talk about mirrors, right? We're going to talk about mirrors.
Before you get into this, what does this have to do with physics?
Well, because we describe the photons of light, how they interact with the mirror and how they make images, right?
Yes.
Because do you agree, every time you look in a mirror, you see an image.
I'm scared every time I look in the mirror.
And did you notice it's a mirror image of you? Like your left is your right and all that?
Yes. Okay.
Yes, exactly. So we explain all that.
Okay.
And one of the things we can tell you is that you only need a mirror half as tall as you are to see your entire body. So I have one right out here out front, Emily. So I think we got to go out here out front.
Okay, you want me to go in front?
Yes, I do, because I'm going to hold this up to be your height right here. You turn around.
Okay.
And then I'm going to hold this up to be your height. And do you still see? I've got this.
Oh, yeah.
Half of your height is where that green line is.
Oh, yeah, there I am. Look at me.
That's your whole body.
Oh, my hair in the back. It looks like Top Ramen. Oh, okay. Oh, there we are.
There we go. There, I got her now. There we go.
Okay.
You can see that. So you only need half the mirror. And see, AJ's trying to pollute the show there back there. You see that, guy? All right. So that's our first thing. And the reason is because the light comes in at the angle of incident and is reflected off at the same angle. So you need half a mirror, right?
Half
a plane mirror.
A mirror half my size.
That's right, to see the entire
thing.
Because of the way it works.
Okay.
But we want to talk about curved mirrors today, right?
All right.
So I've got a simple one here. I've got two different curvatures. You can consider curvature like this, that would be concave, and then around, that's convex, okay?
Yes.
So I have one here in my little stand here, and if I look in this mirror, you're gonna, let's see if I can show it so the people can see it too. And if they can see me, and I can see my big head. This is like a cosmetic
Ready
mirror.
for your close-up there.
Yeah, look at that. Yeah. And Don's not afraid to show his face, man. And then out here, I can see the whole studio.
Yes.
Check this out. I can see the whole entire studio. And all it is a different curvature versus convex and concave. Now, I've got the same thing here, Emily, in giant version.
Yeah, I like it.
Okay.
We have these in the hallway where all the hallways converge so that there are no accidents in the hallway.
Exactly. And this is the mirror that the classic says the objects appear closer than they are. Exactly. It reduces, the magnification is smaller, but it puts everything in perspective. It shows the entire screen.
I can see everything. All these people back here who are trying to hide,
we see all of them. Look at them. They're all back there.
AJ's back there. We see them all.
You see the whole back of the studio. Exactly.
This is convex.
This is actually like this, convex. This is like the kidney bean in Chicago. You ever heard of that?
Yeah.
They have a giant kidney bean. You've been there.
Yeah.
It's all the curvature. You remember how you can see images?
Yes.
That's what's going on there.
What a weird thing that is, that kidney bean. We need one of those in Fresno. Maybe you and your science students can make that for us.
Now,
all right, this is
the concave.
Concave, okay.
Now this one, when we show it, it's going to look kind of crazy, upside down until we all of a sudden get in there close.
Why does that happen?
And now all of a sudden we're inside the focal point of this.
Yes.
And we get a big, giant virtual image that's upright. But when we go farther apart, you can see, we can start seeing it upside down.
Why does that happen?
Because now you've flipped and you're outside the focal point.
Oh, okay.
So we'd actually have to go into ray diagrams, but the physics explains it exactly. We use ray diagrams that show the light coming in, the way they intersect, so we can make every image the way it is. Go ahead.
So the physics part of this is the way the light hits the mirror.
Exactly, and the way the light rays come in, incident, and reflected off at the exact same kind of angle. Now we could take two of those mirrors in a neat little thing like this, and actually have one with a hole and one where we actually have a little three-dimensional bulldog taped in there. And if we combine them and put them in a certain way, you see it right there?
I do.
It's kind of, I don't know if they can see it on TV, but I think we have to hold it lower.
You kind of see him there. A little red dot.
Let's see if I come out here.
You have to get you have to look down on it.
Let me come out here and see if you guys.
That little guy he's right in there.
Yeah, it's kind of hard. Wait, I think you see it now. The red thing on top, maybe? Yeah, it's hard to see, guys.
All right.
But it's a real image.
One day we'll invite our audience into the studio with Don.
But you agree, you can see that.
Yeah, it feels like I could.
Yeah, you could grab it because it's a real three-dimensional image.
There's nothing there.
It is. The real bulldog we know is in there. And we've set up the geometry, understanding the physics. Now, we want to culminate that by showing a really neat effect.
All right.
We're going to take 2 convex radiation antennas, all right?
Okay.
So I'm going to take this one now, and this is going to be our source.
Okay.
So what I have is this convex mirror that this light is right at the focus and is going to shine out parallel rays.
All right, this is like, oh, okay, let's do it. We have a few seconds left.
You got it. Now over here, I got a match set I'm going to ignite. All I have to do is plug it in. You ready?
Yes,
It's going to be a bright light, too. Here we go.
This is like hitting ants with a magnifying. Whoa, that's bright.
Yeah, it is. Let me hit the matches here. See if I could get them to burn. I see
oh
smoke.
my God, Don, you are starting a fire.
I'm telling you, I'm going to burn it in the studio. Check it out, guys. I told you.
Don.
I can light a fire across the room with light because of the rays, because of physics, because of the antenna. The way it works out.
Crazy.
So we'll go ahead and unplug it so we don't stink up everything.
While we burn the studio down, we're going to send it to break. We're going to come back with CMAC, but Fresno State Physics are going to stick around. They've got some more stuff to show us, so stay right there. If you're under 18 and have a passion for film, the deadline to apply is near. We're joined by CMAC after the break.